Vanakkam everyone. Today we are going to discuss about the Programmable Logic Controller, in short PLC. After completing this chapter, you will be able to define what a PLC is and you can list its advantages over relay systems and identify the main parts of PLC and describe their functions and outline the basic sequence of operation for a PLC. Then you can identify the general classifications of PLCs. First, you must know what a PLC is. A programmable logic controller is a specialized computer used to control machines and processes. The advantages of PLCs are the PLC program can be reprogrammed. The solid-state switches used in PLC can last much longer than relays, and you can implement complex logics in the ladder logic diagram very easily, and you can embed multiple devices in one unit, that is one PLC. The diagnostics are very easily and centrally available, and applications can be immediately documented. You can develop the programs by offline and you can simulate it easily. The amount of space, that is memory needed, will be less only, and the PLC can withstand severe environmental conditions. The drawbacks of the PLCs are the PLC devices are proprietary, that is, the parts from one manufacturer can't easily be used in combination with parts of another manufacturer, which limits the design and cost options. And it is subjected to limitations availability by the semiconductor based systems, and it needs skilled trainers, skilled technicians, so the training cost could be high. The parts of the PLCs are the power supply, the processor module, communication interface, and the I/O module. In the processor, it consists of CPU and memory. The I/O module consists of analog I/O module and discrete I/O module. The power supply supplies DC power to the other modules that plug into the rack. With larger systems, power to field devices is provided by external AC or DC supplies. For small and micro PLC systems, the power supply is used to power the field devices. Usually, PLC power supplies require input from an AC power source. However, some PLCs will accept DC power source also. The voltage range will be 120 volt AC to 220 volt AC. Some controllers will accept 24 volt DC voltage. This is the general diagram of a CPU. The CPU is the brain of a PLC. The processors are either modular or built into the PLC. The processor is optimized for high-speed control and not general-purpose computing. The functions of the CPU are: it executes the operating system and it manages the memory, monitors the inputs and outputs. devices and evaluates the programs, and it may have switch for selecting mode of operation. There are three modes of operation: run mode, program mode, and remote mode. In the run mode, it places the processor to the run mode. It runs the ladder diagram and energizes the output devices. And during the run mode, it prevents online program editing in this position. You cannot edit the program online. Next mode is program mode. It prevents the processor from scanning or executing the ladder diagram, and the controller outputs are de-energized. In this program mode, you can edit or enter the ladder logic program. Then third mode is remote mode. In the remote mode, you can change the processor mode from programmer or operator interface device, and it allows you to perform online program editing. Next is the IO module. So this diagram shows the IO module. The input and output interface modules provide the equivalence of eyes, ears, and tongue to the brain of the PLC, that is CPU. The most common type of IO interface module is the discrete type. This type of interface connects field input devices of the on-off nature, such as selector switches, push buttons, and limit switches. Likewise, output control is limited to devices such as lights, small motors, solenoids, and motor starters that require simple on-off switching. The classification of discrete I/O covers bit-oriented inputs and outputs. In this type of input or output, each bit represents a complete information element in itself and provides the status of some external contact or advises of the presence or absence of the power in a process circuit. Next, analog I/O module. The earlier PLCs were limited to discrete I/O interfaces, which allowed only on-off type devices to be connected. This limitation meant that the PLC could have only partial control of many process applications. Today, however, a complete range of both discrete and analog interfaces are available that will allow controllers to be applied to practically any type of control processes. The examples of analog process are temperature control system, pressure, humidity, density, and fluid level control systems. Then communication module. It is used to establish point-to-point connections with other devices for exchanging the data. Some connections are normally established with computers, operator stations, process control systems, and other PLCs. Communication modules allow the user to connect the PLC to high-speed local networks that may be different from the network communication provided with the PLC. Next, we will discuss the operation of PLC. Generally, the PLC program is executed as a part of repetitive process referred to as a scan. A typical PLC can start with the CPU that reads the status of the inputs, that is called input scan. Next, the application program is executed, that is called program scan. Then the CPU performs internal diagnostic and communication tasks. Finally, the status of all the output is updated. That is called output scan. This process is repeated continuously as long as the PLC is in the run mode. Thank you all. Thank you.